Dr. Mhamad Al Hashimi, and he's going to talk about one anesthesia at one time, one anesthetic at one time. And I am sure you will enjoy his lecture. Welcome, Hashimi.
Thank you very much. Can I just check that you can hear me and see the slides okay?
Yeah, welcome, yeah.
Okay, so thank you very much for the kind invitation and the introduction. I'm not going to take too much of your time, probably half an hour, and we'll talk about the environmental impact of anesthesia. So I'm a consultant anesthetist in SSMC, Abu Dhabi, and been growingly interested in the environmental impact since moving to the UAE of everything that we do, actually. And this is a quote from the father of the nation, His Highness Sheikh Zayed Al Nahyan. And he refers to this land being the UAE. So on land and in the sea, our forefathers lived and survived in this environment. They were able to do so because they just recognized the need to conserve it and take from it only what they needed to live and to preserve it for succeeding generations. And anyone who kind of lives in the harsh summers of the UAE can relate to that and the importance of conserving the resources. His Highness Sheikh Khalifa bin Zayed Al Nahyan again said that the UAE would be doubling efforts to reach sustainability goals as part of the major drive to provide a clear and safe environment that contribute to providing prosperity and happiness for us and future generation. And His Highness Sheikh Mohammed bin Rashid Al Maktoum, the Vice President and Prime Minister of the UAE, ruler of Dubai, again, I quote him, and he said, "We are committed to sustainability, which is a top priority that we strive to implement, taking into considerations environment conservation and balance between economic and social development." So you can see that sustainability is a major target and vision for this country. And it's evident by the recent pledge that UAE made towards net zero by 2050. And every organization will have to demonstrate how it will achieve net zero in its policy. Lots of documentation on the internet. There is the Department of the Environment, so you can go into that website and see what sustainability initiatives are there in the UAE and Abu Dhabi. Lots of stewardship programs, and I'm a bit biased, so I have to tell you about the Mayo Clinic green initiatives as well, and that's all in the public domain. Now, net zero doesn't mean that we will decrease CO2. Net zero means that we just made a commitment that we will produce the same level. So we have immediately recognized that we can't really reverse the detrimental effect of CO2 on the planet, but we've agreed that we're not going to make it worse beyond 2050. What are we doing as anesthesia bodies and societies? So the Royal College of Anaesthetists produces infographics for patients, actually. So these pictures on the right are readily available for patients to see. And it's kind of explaining the impact of their anesthetic on the environment. So they tell patients that if your anesthetist gave you sevoflurane for 1 hour, it's like driving 5 to 10 kilometers. If he decided to give you nitrous oxide, that's like driving 106 kilometers. And if he decided to switch to desflurane, that's more like 200 to 400 kilometer drive as a CO2 emission equivalence. And is the drive to better inform patients and people about the deleterious impact of what we do in healthcare on the environment. But how really bad are fluorinated carbons? And you can see that I just put sevoflurane, isoflurane, and desflurane, and their half-life in the atmosphere is, I think, something very interesting. So when you use sevoflurane today, it will stay in the atmosphere for about a year. Isoflurane will stay for 3 years. Desflurane will stay for about 14 years. Nitrous oxide actually will stay for about 115, I think, if I'm not mistaken. So the effects, which is the global warming potential, that one, the GWP 100. So how bad is that agent compared to CO2? So sevoflurane is 130 times worse than CO2 as its impact on the environment. But you can see that desflurane is 2,540 times worse than CO2 itself. So in combination, it will, if you use desflurane, it will be in the atmosphere for 14 years and is 2,500 times worse than CO2 itself. And you can do the math. Now, if you're interested to see how much impact you're causing on the environment by different techniques, the Association of Anaesthetists of Great Britain and Ireland has produced an app that you can download and experiment with, and it will tell you how much CO2 you are putting in the atmosphere, or how you can improve your technique. This app kind of looks like that. So these are screenshots from the app itself. So you can see in the first slide, I decided to use sevoflurane, which is the yellow canister. If you look at the left-hand side, I put my sevoflurane to 2%, and I've decided to use 2 liters of oxygen and 2 liters of air, which is kind of the default of what we use initially when we set up our ventilator, if it's not the Zeus or the newer ones, the auto-flow modes. And if you do that, you would produce 5 kilograms per hour of CO2, more or less, and you will, it will cost you about £8 per hour. Now, the pound is about 5 dirhams. So we're talking 20 dirhams, more or less, in that 1 hour. And that's the cost of sevoflurane on 2%, oxygen and air mix on 4 liters. If you look at the top right-hand side, if I mix nitrous instead of air and still use 4 liters fresh gas flow, I would have immediately increased my CO2 production. So you can see in the yellow canister, instead of producing 5 kilograms of CO2, I've produced 72 kilograms of CO2 an hour, and the cost is the same. So I haven't really spent much more, but I've just produced more CO2. But if you look at the right bottom hand corner, you will see that if I decided to drop just half my flow from 4 liters per minute to 2 liters per minute, I have half my CO2 emission and I have half my cost. So it makes sense to use lower flows if possible and avoiding nitrous. And that's all with sevoflurane. Sorry. I seem to have frozen out. Yeah, that's it. We're good. So if I decide to use desflurane, it's a completely different story. So this is desflurane with oxygen and nitrous on the left-hand side, which is by default the worst combination on a 4 liter per hour, per minute, sorry. And you can see that I'm producing hundreds, so 335 kilograms of CO2 per hour, and I'm losing more money. So it makes no financial sense or environmental sense to use that combination. Again, I would recommend you to see and experiment with this app if you're interested. So somebody might say, so why should I bother? I mean, one anesthetic, does it make a difference? And I would like to introduce you to the concept of marginal gains theory. And that's when the British cycling team achieved superiority in the Olympics. They targeted 1% improvement in every aspect of the game. And then after a few years, they were unbeatable. So yes, every anesthetic can make a difference, because the sooner we start with change, the more impact that change is going to be evident in a few years down the line. So yeah, I would like to think that even a 1-hour operation saving some of the vapor and reducing my flow would contribute to a better outcome for us all. And so why CO2 is a big problem? So you can see the pictures showing us the change in the UAE. So atmospheric CO2 was 315 parts per million in 1958, but population has grown, urbanization came, and actually we're predicting the CO2 to be about 504 parts per million by 2050. And remember, that's the net zero that we're aiming for. So by default, we accepted that we will almost double the CO2 in the atmosphere, and that's our best bet. Now, so far, we have increased the temperature of the planet by about 1.5 degrees. By 2050, it's predicted to be +3 degrees. Somebody might say, well, actually 3 degrees is not that bad, but hot places tend to get hotter. So that's the average increase in temperature in the planet, but sub-Saharan areas and warmer places will get significantly hotter than 3 degrees. And a rise of 3 degrees is significant because that affects the water, affects the plants, affects everything. So it is a pressing issue. I don't need to reinvent the wheel. So there is this publication from the British Journal of Anesthesia in 2020, and it tells you exactly what you need to do to make your anesthesia more sustainable. So it would give you recommendations about TIVA, about avoiding nitrous, avoiding desflurane, about regional anesthesia and consumables. So if you're interested, I don't need to go through the details. But this is a very well-written article about the environmental sustainability and impact. And actually only early this year, and I think maybe December last year, there was this publication from the World Federation of Societies of Anesthetists, anesthesiologists, should I say. So in essence, whatever your affiliation, you would be represented in this publication. And it's a very strong worded document, in my opinion, because it says anesthesia providers should minimize the environmental impacts of their clinical practice. So we have a duty of care towards the planet and our patients. We should use environmentally preferred medications and equipment, and when clinically safe to do so. And we should minimize the use of waste or producing waste. So we should be more environmentally aware. We should do research to decrease the waste that we generate. And I think because there are so many facets to that project, there should be a local lead. So somebody who takes on that message and try to look at every aspect of procurement and the supply chain, probably, and work with industry to make anesthesia more environmentally friendly. Well, somebody might say, well, actually just ditch all the inhalational anesthetic and just do spinal or do regional. That will solve the problem. But actually not, because you can see these, the bar chart will tell you the CO2 emission, general anesthesia, spinal, and a combined technique. And you might say, well, how come a spinal anesthetic generating more CO2? It's because we're using lots of single-use plastic in that technique. We're washing our hands, we're putting on gloves, we're putting on aprons, we are using more water. So it's we're giving oxygen to the patient, and the production cost of that oxygen when it comes to CO2 is significant. So a well-delivered general anesthetic, it will still emit less CO2 compared to a spinal anesthetic, which was surprising to me, to say the least. We've done a project in our hospital to look at how much actually we're wasting or we are using that is not being delivered to the patient of sevoflurane and desflurane. And that's kind of was one of the technicians, Paul. He came to me and he said, well, we're not using low flow anesthesias that much. And our Draeger machines will tell you how much sevoflurane you've used and how much you've delivered to the patient. So by default, you take a percentage of them. And the historic data showed us that we've only delivered 10% of what we use from the Sevo to patients, and only 20% of the desflurane to patients. And the rest was inevitably just pumped to the atmosphere. And that was surprising to me, and again, shocking. We did a 1-week evaluation of how much we're using and how much flow, so compared to the flow that we're using. And again, we're using less than the historic data that I just showed you, but we're still on average using 3 times what we should be using, sevoflurane and desflurane. So we could be more economical. That was the average waste. So you can see we wasted about 80% historically, and now we're into the 30%. So we are much better, but I think we can still do a better job with decreasing our flow and hence our waste. The best case scenario is that we, in one list, we managed to do only 50% probably sevoflurane waste. And that's with a specific practitioner who uses minimum flow anesthesia very strictly. And desflurane we were unable to drop less than 150% waste. Pediatric and ENT is a challenge. And then when you use high flow for induction with nitrous, you will inevitably use, but just be mindful of that. This is the amount of sevoflurane, desflurane, and soda that we use in 1 week. And even when you read the data from Draeger in their machine and their booklet, it will show you that you can see the bar chart. This is cost in euros. So if you use 4.5 liters per minute, which is deemed high flow, compared to 0.5 liter per minute, which is minimum flow, you will save about you will use only 1/5 or 20% of the cost. And I think that's worth thinking about. So it will count. If you do thousands of procedures, that will be a significant cost. And maybe if you save enough money, you can afford new anesthetic machines. So how can we reduce the carbon footprint? All the information that I showed you, or everything that you need, is in the public domain. You can have any system that will have an environmental stewardship blueprint. Always ask yourself, is this operation actually needed? Does it have to be under anesthesia, or can it be just done under local by the surgeon? Should I do GA or regional? And how can I deliver the best GA or regional? Should I use TIVA? And again, when you use TIVA, it's not just TIVA. You need to be careful how to monitor the plastics, the consumables, and if you put that waste propofol in the drain, it will find its way to the food chain. So propofol needs to be discarded as per your guidelines and policy, and not in the sink, which is the recommendation now. So you shouldn't put propofol down the sink. And can you use the engineering path? So there is lots of volatile capture technologies and destruction, and you can invest in new machines that actually adjust the flow automatically and decrease the use of sevoflurane and desflurane. So I think, especially me, I think I'm more inclined to be more sustainable when it comes to inhalational anesthesia. So I try to drop my flow as much as possible. I stopped using nitrous. Again, as I said, once I use it today, it will remain in the atmosphere for 110 years. So it will affect my children and their children, and I don't want to do that. I started more and more to use the EEG monitors. So all our theaters have a depth of anesthesia monitor. So you deliver age-appropriate MAC, which means that you might use less sevoflurane. And if you want to decrease the impact of every component in your supply chain. You can do life cycle assessment to see how much of that of CO2 burden for each individual set that reaches you, and how can you customize it to be better. We've all opened central line sets and arterial line sets, and or regional sets, and we saw lots of waste that we don't really use. So if you customize them and you work with industry to decrease that waste, it will be helpful. And as a footprint, the operating room is not a massive place, but we generate about 25% of the hospital waste. And most of our waste that we generate is an incinerated waste. So that will be burned and will produce more CO2. So by reducing our waste, we will contribute significantly. So it's, I don't want to frighten you, but I think it's a challenge and an opportunity to create some legacy that we are pioneers in saving the planet and delivering sustainability and playing our part. We are going to implement a prompt that reminds anesthetists to drop their flow if appropriate, because I'm one of the guilty ones that I just sometimes don't remember, and I'm busy with the patient, and half an hour later I look at the flow and realize that it's high, and that's avoidable. If you can practice low flow anesthesia and you're experienced in it, great. And if you can use technologies to capture that sevoflurane and destroy it and not let it go to the atmosphere, that's even greater. And with that, I would end. Thank you very much.